Hello guys, this is Kanan's theory. So today we're going to solve the lead code number 509 Fibonacci series. I think you already know what this topic, Fibonacci numbers. You already have a familiar with this coding in your school days and your college. So let's try to recall this topic. Okay. So I think first of all I will explain the how Fibonacci series works. Okay. After that we will dive into the code. Okay, so Fibonacci is nothing but it's a sequence of adding each number with the preceding number. Okay, so first of all, we have to take two numbers default, and one is 0 and another one is 1. Okay, so we have to add these two numbers and it is stored in another variable. Okay, so after that we have to add this second value and third value and the final stored value. Okay, so after that it is stored in another variable, then it is adding continue, it is repeating and until the given condition. Okay, condition satisfied. Okay, so uh, here okay, so here uh, initially they are initializing value 0 and 1. This is a default value in Fibonacci sequence. Okay, so we have to add these two numbers and store it in another variable. Okay, after that this stored value variables added to the preceding value is nothing but it's a 1. Okay, the stored value is added with the preceding number which is nothing but it's a 1. Okay, so after that this 2 will be stored adding and it is stored in another variable 2. Okay, so this 2 is added with the preceding number 1. Okay, so and add addition of 2 and 1 is nothing but the 3. Okay, so the 3 is added with preceding number 2. Okay, so after that it is stored in another variable 5. Okay, so this 5 is added with 3 and it nothing but it's 8. Okay, so this will continue until the condition fails. This is the Fibonacci working of Fibonacci series. Okay, so let's try to uh, I mean, let's try to convert this concept into the coding. Okay, so first of all, there is a default value to two values, right? 0 and 1. So we can take 0 as a 0 value is initially to the a variable. Okay, and 1 is initially to the b variable. Okay, so here two variables are used. Okay, so after that we are adding this zeros and 1. It is stored in another variable c. Okay, because we have to add these two variables, right? All these two values, right? So it is stored in another container, right? That's why we are using another variable c. Okay, so this three variables going to perform this def Fibonacci series operation. Okay, so after that we have after that the stored values moved to the a variable and this and the value, I mean the value in the b is stored moved to the a variable and the value in the addition of a and b is moved to the b. Let's try to the uh, let, let's try to understand. Okay, so I already say the default values a and b, right? So let's check it's a default default value. So we can't change this default value. Okay, so a and b is a default value. It's about 0 and 1. Okay, so we are adding this 0 and 1. It is stored in another variable, but it's just c. Okay, it's something but it's just c. Okay, so that's why zeros and 1 adding to 0 and 1, it's something but it's 1. Okay, so then we are moving this b by value into the a variable and addition of a and b is nothing but it's a c. The the value in the c is moved to the b variable. You understand? So this after that we are doing the after that we are doing the iterations until the condition fails. Okay, so here three variables are used to perform the entire Fibonacci series operation. Okay, so we are switching the I mean we are swapping the value. Okay, that's nothing but it's just swapping the value. Okay, we are swapping the b value into a and the c value into b. Okay, this is how the program works. Basically it's the addition of preceding numbers. Okay, so to add these preceding numbers we have to switch the values to the another variables. Okay, so let's try to uh, write in the code. Okay, so lead code number 509 is a Fibonacci series number. So we can be able to solve this code into another approach is recursion method. I will tell in the at the end of this video. Okay, so first we try to solve in the basic method. So I already say if n equal to 0 means we can nothing, it's nothing but it's 0, right? Because if I mean it's like if n is equal to 5, which means the output becomes output from I mean, the Fibonacci operation happens from 0 to 3 because 1, 2, 3, 4, 5, right? So if the Fibonacci series value, the sequence number is given as 5 means the output, the final value is 3, right? It will be returned. Okay. So actually they didn't ask about the sequence number. Sequence means 0, 1, 1, 2, 3. They didn't ask the sequence. Okay. They ask what is the final output? What is the final value? Final value we getting from this number. Okay. So if n is equal to 5 means the final value is 3. Okay. If n is equal to 6 means the final value is 5. Okay. The final value is 5. Okay. So based on the number given is which is given in the questions, we can able to the sequence will vary. Okay. So if n is equal to 0 means, if n is equal to 0 means nothing but the output is directly written 0 because it's a default value. Okay. We can't able to modify this value because it's a default value. Okay. So you can able to return directly 0. Okay. So else if n equal to 1. If n equal to 1 means it's nothing but it's a 1. Again, it's a default value. We can directly return this 1. Okay. So we can directly return 1. Okay. So else if both condition fails, if both condition fails, so we can do the upcoming procedures. Okay, let's write this syntax. My God, oops, oops. Yeah, okay. Let's move to the else comp. Okay, so here what we are going to do here means, so I already say we are declaring the first a variable is 0, a equal to 0, and int b equal to 1. Okay, so this is what we discussed in the notepad. I just taken this similar. Okay, we have to we have to repeat the process continuously, right? That's why I'm using the loop. So and also we know the iteration number of iterations in the entire loop because the iteration number is given in the questions, right? If iteration is not number, if it's not, if the iteration we didn't know about means we can use while loop, but we know about the iteration number of iterations, so we can directly use the for loop. So I less than, so yeah, yeah. So here we can't able to use the 0, we can use 2. Okay, why? Because the 0 is for this a variable and 1 is for b variable, so we can move this iteration from 2. Okay, so because if n is equal to 0 means we are returning directly 0. Okay, if n is equal to 1 we return directly 1. Okay, we didn't change anything from this, right? So so 0 and 1 is already happens in this if and else if block. So here the two iteration starting from 2. Okay, so 2 less than 2 less than or equal to n is nothing but the question given and I plus plus. So then here the main part occurs, c is equal to a plus b. Okay, I didn't change anything what I'm discussing previously. Okay, I just explained what I did here. I just directly convert into code. Okay, so here c equal to a plus b. Yeah, that's already given. And again we have to swap the variable, right? So already same, the value stored in the b is moved to the a, and value stored in the c is moved to the b. Okay, so finally we got the value, and then we will return the c. Okay, so we given the value c. Okay, let's try to run this code. I think it's working. uh, uh, oops, oops, problem. Oh, I didn't initialize this variable, so I just declare this c bs output because the value of c is stored already stored in the b also, right? So I'm declaring b as output, and I am declaring int c inside this local variable, inside this local loop. Okay, so I think this else, I think the else do not need because so if this if any of this condition is satisfied means they will directly return the value means why need to leaving the else block. Okay, So I think this else if also don't need. We can give us that is a two if conditions. Okay, because if first if condition is satisfied means it will directly return the output return zero. If not satisfied means go to the second loop, second if, right? So if both if condition is not satisfied means you will move to the forward, right? So I think you don't want to be given this loop. So yeah, I just changed what is this? Oh my god. Hmm. Return B and into C. Okay, I think now the code is perfect. I just try to run this code. Yeah, it's working. Runtime is 0 millisecond. I just submit this code. Uh, oh my god. Yeah, it's 3 millisecond. Okay, fine. It's a good approach. So we can able to solve this code in another method called recursion method. Okay. So let's try to understand this recursion method. So recursion method is nothing but it's a because why we not to going to recursion method? So recursion is nothing but it's a repeating. Okay. So if the same concept is or same condition is repeating continuously means we can use recursion method. Not a condition, it can be able to be addition or subtraction, anything. Okay. So any operation repeatedly performing the same operation means we can able to use recursion. For example, factorial or whatever. Okay. So why I'm using why I'm telling here means here we are doing this we are doing this swapping method for repeatedly. Okay. So we didn't do that much of enough, right? So we are doing this swap method for repeatedly. Okay. For each iteration. So we didn't change much thing inside the loop, right? So we can able to use the recursion method to solve this problem. Okay, let's try to understand this recursion method. To do the recursion method, uh, uh, this for loop we can't able to. I mean, we can't able to use this for loop. So we just use this if else condition and if else if and in else block we can directly return fib of n minus 1 plus fib I mean fib of fib of n minus 2. So this is the condition of this is the condition of Fibonacci series. So um, yeah, this return is not used. I mean this is become it's not used. Yeah, mm, I just try to run this code. I think it will work. Yeah, it works. Okay, so I will explain this code how it works. Oh my God, the time complexity is much greater compared to the previous method. Okay, fine, but you can able to understand this method because it's another tricky method which you can able to ask in an interview or uh, uh, any other purpose or in your college level or any other coding role in your interview or your okay, placement types. Okay, so this recursion method is important method which can basically in my interview the interviewer asks this recursion based problem. So to write the paper to write the code in the paper. So this method is very useful for for the task for the task whose repeatedly works means you can use the recursion method. So I will explain this how it works. Okay. So basically, if I take n is equal to 5, okay, n is equal to 5 means if I take n equal to 5, okay, so inside the loop, I mean inside the function, what will have? Me- Wait a second, wait a second. Okay, what will check? What will happen here? First, if condition checking n is equal to 5, yeah, definitely not. It's condition is not satisfied. Then let's move to the else if block. Else if block n is equal to what? Definitely not. And because n is equal to 5, right? So the condition also not works. So let's check n is equal to 5. Okay, the condition is also not satisfied. Then it's moved to the else block. Else block fib of n minus 1 plus n minus 2. So this fib means it's nothing but it's a Fibonacci. Okay. the whatever function is given above top of the code, that it is directly given in the return function. Okay, so fib of n minus 1 is what? 5 minus 1 is what? 4, right? 4 plus 5 minus 2 is what? 3, right? So which means fib of 4 plus fib of 3. Understand? Fib of 4 plus fib of 3. Fib of fib of 3. Okay. Again, fib of 3, right? So again, this fib of 4 is checking into the same same function. Okay. So fib of 4. 4 equal to 0? Definitely not. 4 equal to 1? Definitely not. Okay. It's moved to the else block. Else block, what will happen? If fib of 4 means fib of 4 minus 1, what will happen? 4 minus 1, fib of 3. Fib of 4 minus 2, fib of 2. Okay, this will divide into branch continuously. Okay, so I just shown the figure, we can able to understand. Okay, so in the return function, in the return function, wait a second. Okay, in return function, what I given in the return function means fib of uh, fib of n minus 1 plus n minus fib of n minus 2, right? So if take let's take fib is equal to 5. Okay, so fib is I mean n is equal to 5. Okay, what will happen? N is equal to 5 means in return function what will happen? N is equal to 5, n minus 1 4, and plus n minus 2 3, right? So that is the branches divided here, 4 fib of 4 and fib of 3. So again the loop will again the function will re-enter. Okay, so because this fib is nothing but it's a function, right? So it's a function because whatever code is here is directly move to this fib. Okay, so this fib will return, this fib will again move. What will happen? Fib of 4 will divide it into fib of 4 minus 1 3, fib of 4 minus 2 2, right? So again this fib of 3 is moved to, they are divided into two parts. Fib of 3 minus 1 2, fib of 3 minus 2 1. Again it is moved to the fib of 2 is moved to fib of 2 minus 1 1, fib of 2 minus 2 0. Okay, now the condition will be returned, which means now the condition will be written. What will happen means, so after moving to the final part of fib of 1 and fib of 0, what will happen means it will be reverse stacking. Okay, so fib of 1 is what? Fib of 1 is what? 1 is what? Return 1, right? So the output of fib of 2 is 1. Okay, fib of 1 plus 0. Okay, so fib of 2 is equal to 1. Okay, fib of 2 is equal to 1 means fib of 1 is equal to, fib of 1 is equal to 1. 2 plus 1 1 3. Okay, 1 plus 1 2. So again the fib of 3 is equal to 2, and 2 is and 2 of I mean fib of 3 equal to 2, and fib of 2 equal to, what will happen? 1 1 plus 1 plus 0 1, right? So 2 plus 1 3. Okay, fib of 4 is equal to 3. The then we move to the another branch 3. In the fib of 3, it is divided into 2 and 1 because n minus 1 and n minus 2. So again the fib of 2 is divided into n minus 1 n minus 2. Here don't think why this fib of 1 is not divided, because already say that in that code n is equal to 1 means return directly equal to 1. That's why it's not divided. Okay, that's why it is not visible. Okay, so here the fib of 1 is equal to 1. Okay, here the fib of 2 is equal to fib of 1 plus fib of 0, which is nothing but 1 plus 0 1. So this fib of 2 and fib of 1 is adding together, and it's nothing but it's 2. Okay, so here finally fib of 1 1 plus fib of 2 1 2, and finally it is added together 1 plus 2, it's nothing but it's 3. Okay, so this is how the code works. Okay, so actually it's difficult to understand because recursion concept is very tricky to understand. That's why it's asked in most of the interview questions. So this concept is repeatedly repeatedly doing this, right? You know, because I mean, so in Fibonacci series actually we are swapping the values to the another variable continuously, right? So here the same concept is happening, but it is in a recursion mode. Recursion mode is nothing but the all the values inside this function is a function is executed repeatedly. Okay, so here this totally 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. What will happen here means this entire function is iterated into 15 times. Understand? So the code length of the code is very simple, but the iteration is very high. And also the space complex, I mean, how much space it takes means very less. Okay, this code also actually space complexity is very less, but time complexity is very high because here the totally 15 number of I mean 15 function is iterated repeatedly in this entire in this value 5. Okay, which means inside one 5 the iteration number of iteration happens is 15. Okay, so which means the time complexity is very high compared to the previous code. In previous code we can able to see the we can able I'm using for loop for limiting the iteration, right? So in that for loop only if n is equal to 5 means only 5 iteration will be happen. I mean only 3 iteration will happen because we are adding this value into previous code. I mean above the for loop. Okay, so only 3 iterations happen. I is equal to 2, I is equal to 3, I is equal to 4, I is equal to 5. Okay, only 3 iterations happens in that for loop. Okay, so here 15 iterations happen. So that's why the time complexity is very high compared to the previous code. In the previous code, the time complexity is 3 milliseconds, but is in this code, the time complexity is 6 milliseconds. Okay, so time complexity is high, but the number of lines and the space complexity is very low compared to the previous question. So also this is a tricky concept. That's why I'm asked in the interview level questions. Okay, so I think you didn't understand about what I'm saying. Okay, you can try to get it into this concept, and you can write in notebook. Okay, so basically each function, I mean each iteration is repeated. I mean, the function is repeated continuously. Okay, so what I written in this code is repeated continuously until the function will get 0 or 1. Okay, if the function gets 0 means it will return 0. If function is 1 means it will 1. That's why the entire leaf of all the branches 0 and 1 because 0 or 1 because the the condition is given in the code, right? So in the code you can able to see n is equal to 0 means return 0, n is equal to 1 means return 1. That's why it halt in that code, halt in that time. Okay, so sorry. So basically the function is repeated continuously. Okay, you can take paper or pen and paper, and you can write this function continuously. I mean you can write this function which you will be able to understand very deeply about this concept. Okay, so I think you will understand what I'm saying. Okay, so if not understand means you can use the previous code also. Okay, it is asked in the individual questions, not a uh, not a it is one of enough important concept. Okay, you got to focus this recursion, but fine. Okay, so I think you understand the Fibonacci concept. It will takes more time to I mean the time takes more. Okay, so thanks for watching this video. We will see in the upcoming videos.